Okay, dun 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 dun. Yes, that's my new catchy little one I've ready. Dun 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 dun. Hey, welcome. Yes, welcome to another fun-filled video. Hey, oh, Mr. War, I don't know. I think maybe I've had too much coffee. Let's talk math. Whoa, what happened there? That was pretty cool. I didn't try to do that. All right. Disappear on my command. Disappear, thank you. Delete. And you, little dot. All right. Let's take a look at our objective today. It says divide 2 and 3-digit dividends by 2-digit divisors with single-digit quotients. Oh my goodness. You know, we've done this. This is exactly the same objective we've had. This particular video is, again, simple review. Now, I think what makes this important then is if we're having a video and each lesson is kind of building on each one, or even having two identical objectives, must mean this concept is really, really important, and division is, and they're trying to demonstrate that division in this format, showing it this way. So we're going to kind of be doing similar problems that we have been doing. Let's go ahead and get started with some fluency practice. All this is again, we did this before. Okay, we found the rounded number of the divisor when we were trying to do an estimate of our division problem here, and we can see that 17 is clearly close to 20, and 60 works really well because 6 and 2, again, very compatible, and now we just have 6 divided by 2, which is 3. Now, now what we could do is we could actually check our work by simply saying, well, let's go ahead and do the actual problem. So if we do the problem, you see 61 divided by 17. Well, 17 twice, I know, is 34. 17 3, I think that's 51. So you see I have 10 left over. Now, we could kind of check our work this way. So 17 times 3 equals 51. Plus 10 equals 61. Okay, so this seems pretty clear. No problems there? All right. So, I mean, I know I've said kind of like, you know, a caveman could do it. Even a scarecrow could do it. We even learned, you know what, that even a black cat with yellow beaming eyes could do it. But did you know that a witch could do it? No. Yes, even a witch could do it. That's been my new thing here. Huh? Slip, slide, away. Okay. All right, Mr. Warren, let's get back on business here. Here we go. Let's move on to our actual application, our application problem. Let's look at this. 105 students were divided equally into 15 teams. If that problem doesn't tell you exactly what we need to do, because it's right there. Okay, so that's kind of nice, I think. And we're going to divide that that dividend into 15 teams. So let's go ahead and do that. Let's divide that in 15 teams. And is there a reason why this guy's not disappearing? Oh, how strange. Now he just disappeared. Oh, something spooky's going on over there. What's the deal? I'm supposed to. What's up here? Maybe I'm just. Okay, I'm just imagining things. Whoa, it's a bat. The bat was doing something to that code letter. Wow. All right, I'll let you stay. You're kind of cool. I like bats. Only flying mammal. I'd like that. Okay, so let's go ahead and just leave the bat there. Let's go ahead then and start to solve this. Let's just take the regular uh, algorithm, if you will, the division. We'll take 105 students, and we're dividing this by, well, 15. There's 15 teams to see how many players were on each team. Well, let's see, 15 times 5, 75. 15 times 6, ooh, I think it's like 90, and then another 15 would be, ooh, 105. Oh, that would be like 7 times. Check my work. 5, 55, 7, 10. Yes. Works for me. 105. Okay. Done. Yes. So that would mean that how many players were on each team? Well, 7 players. would be on each team. Hello, Bat. And if each team had 3 girls, how many boys were there all together? Ah, okay. Boy, that's a tricky problem. Well, for each team, if each team had 3 girls, automatically means then that there would have to be 4 boys to make the 7 on each team. So they want us to multiply. So if there's 4 boys on each team, and there were 15 teams, if you recall, then I could take 15 times 4. And 15 times 4, well, that's a nice one. I don't know if this, I mean, I know my 15 times 4 because of the clock, the quarter hour, 15 minutes in every quarter hour. However, you could always break numbers apart like that, because doubling this might be a little bit easier for you to think of. 15 times 2 is 30, and then you double it again, which is 60. So that'd be 60 boys all together. Okay, great question. Great problem. Ding. Time to move to the next page. And thank you very much. So now, well, I got another problem. Let's put another one up here. Let's see. Come on down. And okay, good. There must not be a bat there, but that A, it was really kind of weird. It's kind of scaring me there. And so I was, yeah, I was kind of scared. I admit. All right, I was a little scared at first, but not so much now. I mean, now that everything seems safe around here, no big deal. Oh man, whoa, whoa! Right when I said that. Now is that the same bat or is that another bat? And is there a reason why he's upside down? Is he sleeping? Is this how bats sleep or something? Whoa. Okay. All right. Don't get too touchy. All right. Goodbye, bat. 236 divided by 39. Yes. We could go back and kind of do this. Is a pretty large number. Maybe you want to do our little estimate, first, and do our little bubble, and then solve. And then we could always check our work. We've been doing this a lot. Whew, very sloppy. So we always kind of round this right off, right? That divisor. Run around it, 40. Something compatible with 40 that's close to 236. Well, 24 and 4. Yeah, that would be perfect. Okay. And then, of course, we got the 2 powers of 10. So really all we have here is 24 divided by 4, which equals 6. And these are all just equivalent because it's basically an estimate. Well, let's go ahead and solve it. 236 divided by 39. Ooh, large number. Now, the way I kind of was teaching you guys earlier now is to kind of think of this first number and how it will go into that number. And really what this is how many 30s are there in like 230s? Is that kind of like what you're thinking of these 2 digits here? And, 7 times would be nice. So 7 times 3 would be 21, and that would fit in there. Let's do 39 times 7. 63 carry the 621, 20. You know what? That's too large. I have to back off with this number going in only 6 times. And 1 less, that means I'm taking off 39. Let me just subtract 1. Ooh, we need some help here, which means you're going to be 4. So 234, that sounds good to me right there, with a remainder of 2. Now, of course, the way we can check this is by multiplying that through. And so we would take the 39 times the 6 that we had here, and we actually just did that. 234 plus the 2 gives us 236, and woo! There it is right there. Okay, pretty simple. So the estimate quotient of 6 was right where we needed it to be. Pretty nice. Okay. We do one more. Let me see. Yeah, let's do another quickie. All right. We'll get out some blue. And probably want to do this too. And let's see. Let's make that right. Let's do 712 divided by 94. Okay, you guys are getting really fast at these now. So if we want to do their same model, to me this seems like we're getting to the point where this is pretty easy. It's getting really sloppy because I'm going for speed here. So again, 94, you could go 90, 100. Let's do the 90, pretty close. 71, well, 9 times 8 is 72, so why don't we just go 720? You see that how close that is? 9's compatible with 72 because 9 times 8 is 72. That bad deal, but because now we have something much easier to manage, okay? Again, these are just equivalent because it's an estimate. We're going to go ahead and solve and put that 712. Let's divide that by the 94. Now, again, my little trick was how many times will 9 go into 71? Well, see, 8's too much. So we'd have to go off one, right? So let's do 7. Oh, I'm sorry, I should put the 7 over there. Oops. And let's figure out what that would be. And coming back up here. So 94 times 7. That's what, 28? Carry the 2, 63. So 658. That's what we're looking for. Okay. Subtract. Ooh, a lot of regrouping here. 6. Oh, we need to make that 10. Now we have 4, 5. 54. And that would work. Okay. Now we have a huge remainder. But now we would basically, same thing. 94 times 7. Which you already know, is 658. 658 plus the 54, 12, 10, 11. Okay, seeming pretty easy to me. So when we pick the estimate, this pretty much, I mean, I think this pretty much says it all. Okay, and so does that. So let's call it the end of this math video. And I know it's sad. You probably want to get out your tissues. It's just a sad thing when the math video comes to the end, but it is the finale. This is it. See you next time.